Thank you, Alex, for the amazing introduction, and thank you everyone for being here. We're super excited to kick off this very thrilling event. The venue is something, never seen before. So today we're gonna take you on a little journey to show you how we've been working on making beef, but with a slightly different process, as you will see. As Alex mentioned, we are based in Maastricht, in the Netherlands, and this is our growing family of more than 160 people coming from 36 different countries. And actually today we are the largest scientific group working on cultivated meat. Of course, out of all the people you see in this picture, we have different responsibilities. And both Francesco and I were on the scientific team, which means, as Alex mentioned, we work on the optimization of our upstream process in different ways. I'm more working on the fat tissue engineering side of things, and Francesco is more on the bioprocess development side of things. But where we come together is actually to take care of the application of our cultivated meat. And in other words, we're the ones basically making the burgers and taking care of our product development approach together with our product development team. As I was thinking and preparing for today, I remember when I followed last year's event, CMS 22, I remember Justin Colbeck opened the event, and I remember how he mentioned that plant-based was actually facing the first setbacks and how we may very well be the next ones. And that definitely happened. We started to see more and more of these headlines coming out, and it's not an easy time for us in cellular agriculture and cultivated meat. The bigger the challenge, the bigger the spotlight. So I like to think that it's all part of the process, and getting critiques is part of it in the end. But how are we actually doing today? Sure, the shift away from meat is not happening as fast as some of us actually expected. A lot of meat eaters haven't really changed their habits despite the many different plant-based products that we start to see out on the market saying, we're meat. It's amazing. As a result, I'm talking about Europe, we're from Europe, we're a bit more familiar with that. And in Europe, the percentage of vegetarians is only between 5 and 10%. And Europe is a pretty forward-thinking country when it comes to vegetarian diet. And this is for many different reasons, of course, but mainly it's because our relationship and our basically our love for meat comes from our culture, from our tradition. In other words, when we back in the days when we would eat meat, we were actually likely in a safe place with people that we love, and that is a pretty hard emotion to get rid of, and that's what makes it so deeply engraved in our brain, in our hearts. And considering this, it's a pretty tough challenge. So for this reason, we need all the tools that we can think of. So it's not going to be only plant-based or alternative protein or cultivated meat. It's going to be a mission for all of us. However, for this exact reason, I think that cultivated meat has a really high potential, because what it means is that people can keep their tradition as they were. They can keep eating what they like and what they love. We'll just make sure that no animals are killed in the process here. And to get more people to join our revolution, we need to consider something. What you see here, it's an innovation adoption curve, which basically shows the average distribution of people adopting or being interested in a new product over time. As you can see, the first one to be interested in us are the early innovators and the innovators and the early adopters. Like people that are passionate and super motivated and thrilled by the mission, and they immediately understand how cultivated meat can actually be a good choice for all of us in making the world a better place in a way. However, to reach commercial success, and that is important because that is actually the only way we can actually bring the change we want to bring. That is not enough. The mission is not enough. We need to conquer the majority of people to start to be able to bring that change. And we need more than just a mission. What else do we need? Price is crucial, that's true, and it needs to come down. But we also made some pretty good progress over the last year. So, and that is because our R&D efforts in optimizing the process have given their fruit, and also because we've allowed the supply chain to evolve with us, and actually we start to see more and more industries or more and more companies focusing on making cell nutrients that are not pharma grade anymore, and we're switching towards food or even feed grade, as well as manufacturing companies that are focusing on making the process more efficient for bioreactor making and bringing the cost down, which actually today is a really big cost driver for us. So the ecosystem around is evolving, but the price is not the only thing. Because otherwise we would probably all just eat vegetables, right? They're a lot cheaper than meat, but as we've just seen, that is not really the case. So we need more. And what is that extra factor that we need to get right to get to that majority? It's the product, it's the taste, it's the experience, and it's the emotions that we feel when we go ahead and eat meat. Actually, think about this. When people make their food choices, the taste is by far the main driver here. It's not the price. It's definitely not the sustainability, unfortunately. It's the taste here. And also, this is the main reason why people are struggling with switching to a vegetarian diet. They're just missing that part. It's not there. And we've also seen how not getting this right, not getting the experience and the product and the taste right can actually draw setbacks for the product, for the company, and possibly even for the field itself. So that is fundamental. And this is always a tough one. Like each time I see this picture, it's really hard to focus on what you have to say. When we showed this to Mark Post, one of our founders, he defined it as obscene. But we definitely took that as a compliment. Anyway, so experience and taste, really fundamental aspect for consumer adoption. And so how do we do that? Well, it's very simple. We just have to replace beef with beef. And we believe that is the only way to actually bring the same experience and the same culinary experience and same nutritional value. And this is the only channel to get through mainstream consumer acceptance and to really be able to start to bring change. So for this reason, we want to focus on cultivating real beef muscle and real beef fat to deliver on what we promise. And what it means for us, more in detail, is that we focus on cultivating tissue and we focus on maturation over than just proliferating a lot of cells and then just chunking in a product. At Mosa Meat, we've always had this very clear in mind since day one, and we've taken some very relevant decisions in our early days to achieve this pretty ambitious goal. And for this reason, we've always leaned toward enabling the natural process rather than modifying this. And what this means is to find cells, for instance, that are suitable with our process without the need to genetically modify this. As well as, of course, focusing on the proliferation part and making it as efficient as possible, but also focus a lot on the differentiation and maturation side of things to deliver on our culinary expectations. And what you see here are some of the results of our focus on differentiation. Those bright colors that you see at the top, they're real muscle proteins that are expressed in our cultivated muscle. And you can see how the composition, but also the structure, even after only 7 days of maturation, they really start to resemble what you find in conventional beef muscle coming, for instance, from a slaughter cow, as you can see on the left. And talking about our beef fat, we can also, the same goes for the fat. We can see how the structure there is starting to resemble a lot more what you find in conventional beef fat. And this is because in animal fat, and in this case beef fat, the lipids are stored into fat cells or adipocytes. And this is a very fundamental aspect of animal fat and of its superiority compared to vegetable fat, because by being stored and compartmentalized, then this fat is protected throughout the preparation of the product. And that means that you're going to have more juiciness and you're going to have more aroma saved in your product, which is slowly going to be released when you start cooking it and frying it. And ultimately, it's going to explode when you go ahead and take a bite out of it. And exactly for this reason, I wanted to dedicate this slide to fat, because it doesn't always get the deserved importance, despite it's actually it's probably the star of the show when it comes to taste. As I just mentioned, this compartmentalization delivers what chefs call the U-bomb, so this explosion of flavor and juices. But besides the structure here, if you look at the composition, you can see how, what you see there, we can call it a fat fingerprint or a lipidic fingerprint of what our fat is composed of. And as you can see, compared to a standard vegetable fat, the fingerprint really starts to get closer and closer and resembling what we find in conventional beef fat. So, just like that, we have our ingredients, we have our cultivated meat, and these where Francesco and I can step in and start to taking care of making something delicious out of what we harvest from our bioreactors, which sounds, pretty straightforward and something easy, but guess what? It's not really. Francesco now will guide you a bit more on our approach on product development, our endeavors, and our achievements that we've seen so far, and can tell you a bit more.
Thank you, Chef. All right. I think that thanks to all the really nice introductions, you have a pretty clear idea of who I am and what I do. And indeed, I have been working shoulder to shoulder with Sebastiano on this project of product development. And so this is really exciting. Now we have the ingredients, and we have to develop a strategy, a way to make it into a product through product development. And since it's the first talk of this event, I'm going to take the chance that we're all still really awake and put us all in the shoes of product developers. And I'm going to give you a general approach to it, on how we can tackle this product development step, which is split into 4 different steps. So the step number 1 that we have to do is to define what product do we want to make. In new product development, the idea generation is an essential step that is also very complex. And luckily for us, actually, we can take conventional meat products as a point of reference, so we don't need to do this new idea development. What we do have is existing meat products that can be different in terms of animal origin, they can be different in terms of flavor profile, but most interestingly for us, they're different also in food structure. And if we look at the food structure of our products, we can recognize 3 different classes. The first class is of products that are ground and then bound, such as burgers, patties and nuggets. The second class is whole cut products, which have a high degree of structure inside because they're directly cut from the animal. And then at last we have emulsion type products, such as sausages. And these are maybe less self-evident, but they're really interesting because what we have is we have a dispersed fat emulsion, which is stabilized by the proteins from our meat. And we can see that the functionality of our proteins here is significantly different, which also explains why often different types of meats are used for making the different products. Now, in the cultivated meat field, most companies, I think, already have a clear idea of what product they want to start producing with, and therefore in which class this product belongs, which allows us to go to step number 2. In this step, what we need to do is that we need to create a conceptual connection between the ingredients that we have from the bioprocess and the product that we want to make. And it's particularly important for us because once we define what product we want to make, this might put some restrictions in terms of what ingredients we need to have, which then places restrictions in the bioprocess. And realistically, changing the bioprocess and adapting it to match the requirements that these ingredients have is very challenging. And what we can do more easily is to take advantage of the manufacturing step in order to bridge the gap that we have between the ingredient and the product. The ingredient and the product. So in the previous slide, I talked about 3 different classes. Why did I do this? Well, it's because each class kind of has these food structure properties, which are then determined by the manufacturing process step. So as we recognize what class of product we are talking about, we immediately have an idea of what techniques and generally what approach to the manufacturing step we can take. And yeah, so once we have this broad idea on how do we get from the cultivated ingredients to the product with more or less what techniques we can use and what process parameters to take into consideration, the next important thing is to be more precise and define what techniques do we use and how do we do it. And if we had infinite trials, we would eventually come up with a very good way, but we want to be structured and efficient. And this needs some sort of strategy behind it. And this strategy is built on step number 3. So making cultivated meat is not trivial, and it's not trivial because we are making ingredients that have a functionality that is unique, that is found in no other material. And so what we really need to do is we need to recognize the value that our ingredients can give, and we can only recognize the value if we understand what their unique functionality and properties and characteristics are. So in order to explain myself, I'll give you 2 examples. As a first example, we have the cultivated fat. Sebastiano already talked quite a bit about it. We know that the fat is contained within the cell, and this means that it's retained to a larger extent, and therefore when we eat the products, it's still stored in the product, and this means that it will have an impact on the mouthfeel once we're chewing on the product. He also mentioned how the fatty acid profile is very similar to that of conventional fat, which implies that physically the melting point is similar. And therefore, we can also expect the cooking behavior to be similar. And at last, we now understood how fat is so essential in terms of the final aroma of the product. And this is great news for us because we indeed recognize this really meaty, unique character within our cultivated fat. If we move on to the next example, we have cultivated muscle. In this ingredient, we have the proteins that are differentiated, which then leads to an advantageous nutritional profile. These proteins are also arranged into fibers, and these fibers are able to A, bind water, which leads to a more juicy product at the end, and B, give a fibrous structure, which then has an impact on the texture. These ones here were just 2 examples. Of course, ingredients can be of different types. We can have undifferentiated cells with their respective characteristics and properties. We can also have materials, and this is very important because in the bioprocess, we often need some materials to get the cells to grow and differentiate, and therefore these materials also stay as part of the ingredients. And these materials will therefore have functionalities that will have an impact when we make the final product. This brings us to the last step. Once we recognize what the functionality, the unique functionality of our ingredient is, we can really tailor the whole idea of process manufacturing that we developed in step 2 in order to preserve these characteristics, or even better, to enhance them. And this means, for example, not to be destructive with our ingredients if we want to preserve the structure. This is just an example among the infinite things that we could consider. Yes, so what I mean here is that once we define the process manufacturing and examples of techniques that we regulate are, for example, the agitation speed, the temperature, the pH, these are very in detail, but there's much broader approaches that we can also consider from existing technologies. And the same way that the process manufacturing that we defined allows us to bridge this gap between ingredient and product, we can also bridge the gap between the same ingredient and another product, which then allows us to make from the same ingredient a number of products. And this is very similar to what happens in an animal, where we have the same animal, and depending on how we process the ingredient, we can reach different products. So now I gave you a bit of a conceptual approach to how we really undertake product development in a way that we make the most out of our ingredient, where we include it in a purposeful way. And what do these 4 steps lead to? I will use the example that we're most familiar with, so the example that we have in Mosa Meat. And this is our goal. Our goal is to make a burger, a patty, that is fully composed of cultivated fat and cultivated muscle. A burger that, in terms of taste, texture, and aroma, is exactly equivalent to a conventional burger. We didn't stop there in Mosa Meat. What we're also working on is in investigating, and we're doing this in parallel, we investigate what the interactions between our ingredients and other plant-based ingredients could be. And this is very interesting, for example, if we have cultivated fat. We found out that this is really able to cover the off flavor of soy proteins. And this kind of let us see what the potential of this ingredient is and the broader range of applications that we can derive from it. But let's go back to the burger and focus on where we are today in terms of our product. This is the Mosa burger. This is one of the burgers that Sebastiano and I made with the support of the whole team, just like all the other burgers in this presentation, actually. And we're very happy to where we got today. We have a really great texture, a great taste, and even the color transition towards throughout cooking is the same as that of a conventional burger. Of course, we didn't get there right away. As I mentioned, it took a lot of fine-tuning throughout understanding the properties of our ingredients. And even now, we continue on developing and improving the recipe. Now, when I say that it tastes, we're happy with the taste and the texture, I mean this. When we start biting in the burger, on the surface, we have this very crunchy layer that is very roasted meat-like. And as we continue to bite deeper into the product, we have a dense structure, which upon chewing is actually also tender. Once we're chewing, the first noticeable thing in our bite is the really unique, meaty character that our fat gives. And after that, we also actually notice some metallic and earthy notes, which are typical in a conventional burger. The experience is not over once we finish eating the burger, because at the end, our tongue is covered by this layer of umami taste, which is, of course, very unique in terms of meat products. So overall, we're very happy with where we got today, with what we did, and what we were actually wondering is, what would someone who has eaten high-quality meat all their life say about our burger? That someone for us was a 2 Michelin star chef, Hans van Wolde. He came to Mosa Meat, we sat together, and Sebastiano and I actually cooked a burger for him. And the experience was really incredible. So at first, he was really excited about trying the product, I guess as we all would be. And then he was emotional when he was actually having it in his plate and when he started to bite it. And then after he ate it, he was amazed. He could really not believe that what he ate was prepared without slaughtering an animal. And this experience has been very incredibly motivating for us, because we really want all the customers out there to be able to also feel this excitement and this amazement when we eat, and really to let them realize that replacing beef with beef is a great opportunity. Okay, so this gets me towards the end of the presentation, and I described a bit the approach that we took towards product development and also what product we ended up with. But I should mention that just like us, there are many other companies throughout the world making great work on producing outstanding products. But what we should not forget is that even though we're different companies, we're all in the same boat, and we're all fighting for having the planet a place where meat consumption is no longer an issue. But what being in the same boat also means is that if one of us puts a product out there that is not as good as it should be, it will have an impact on the rest of us. So I really think it's the responsibility of each of us, each scientist, each product developer, or each person involved in the field, to ensure that the only products that we put out there are outstanding and they can really convince people in terms of what the potential of our field is and why we should really adhere to it. And so with this, I just hope that it's clear that product development is the way to actually achieve this goal, to impress everyone. And I hope that throughout the rest of this event, we can really learn from each other and also inspire each other on how we can approach better, new, and kind of more effective approaches to the product development. And with this, I would like to thank you for your attention, wish good luck to the next speakers, and Sebastiano and I will be here happy to answer questions on stage and also later off stage. Thank you.
Awesome. Thanks, guys. That was really interesting. I especially liked your slide on the functionality of each of the ingredients. But looking at that, it made me think some of those functions you can get from non-cell-based ingredients. And so I'm wondering, maybe that runs counter to the philosophy of replacing beef with beef. But if you're interested in texture, for instance, why not focus on a hybrid product or make a hybrid product? What do you think about that from product development perspective?
Right, I understand. May I ask you what functionalities you're thinking about that are also present in plant-based?
Both texture as well as potentially the nutritional content of the protein.
All right. Okay, I see. I think the key here is that our ingredient contains all of those functionalities at once. So whilst we can give texture, we can also give the nutritional properties, but we can give water binding. And this, for just to give you an idea, this water binding added functionality is what will take our product to, or our ingredient to a next level. So I think it's really the combination of all these properties that make it like meat. So in plant-based, indeed, we can approach some of these qualities, but the combination will be very hardly the same.
So I guess what you're saying is you couldn't get those same set of properties from a mixture of kind of plant or other types of ingredients, or it would be more expensive or something.
Yeah, indeed. I don't think we could do, and that's why we're actually doing cultivated meat. That's the idea behind it.
Thanks.
Yeah.
Any other questions? Okay. Oh yeah.
I think there's a question.
So for those that are maybe a little bit farther from that mic, I'll run it to you.
Hey, very, very interesting. I want to ask, from a perspective of measuring what you're saying that you're building, how much of that is humans saying that it tastes good versus, something that you're actually measuring?
Very good point. Well, that's the initial step, right? So also for consumer acceptance, we're aiming towards consumer, but that is not where we stop. So for instance, for just as you've seen the lipidic fingerprint, we're also measuring the aromatic fingerprint. It's just in the development, in the pipeline as we speak, so it's not out there. Our approach was initially to focus on a tasting panel that we developed internally at Mosa Meat to start to understand what is the sensations and the feelings or the taste and flavor that you can get from having cultivated meat in your product.
Can I have a follow-up question?
I'm sorry?
A follow-up question to that then. So what's the feedback loop then after you get that feedback, or after you get those measurements? Like, how are you actually building that back into the product?
Yeah, for instance, when it comes to interaction with plant-based, for instance, what we look at is our inclusion percentage, for instance. So let's say we have certain results from an organoleptic perspective that, for instance, helps us to, let's say, mitigate or decide how much of each component we can put in our product, because maybe it's not necessary to have so much cultivated fat to just cover the off taste of soy, but also to bring this meatiness that we spoke of. So that is, for instance, something we've done. So there is this looping back, but for instance, by having an aromatic fingerprint, then that helps you a lot more with the differentiation and maturation part, and also with what you expose your cell to, basically. Because by exposing to a certain nutrient, for instance, you can get a difference in your fingerprint.
Thank you.